Hey, self-realized math and history, and we are going to learn about when you assume things in geometry. So, when you see like a figure, like something that looks like that, a lot about geometry is about logical thinking, and a lot of it is about shapes and lines and about trying to find how long or what something is. But sometimes the math problem or your geometry teacher is not going to give you all the information that you'll need. Sometimes you are going to have to assume things, like assuming that if an angle is this, or how long is something, or if it's congruent with another line or something. Well, we'll have to do that in geometry. So, right here are some examples where we can assume things. Things like lines are straight, so we can say straight lines. We can say that. For example, we can say that line BA can be a straight line. We can say that line BA is a straight line. We can also say that line BA can be a straight angle. So straight lines and straight angles can be one of them. The second one is if something is collinear. So we can say that point A, C, D can be on the same line. And since they're on the same line, therefore they can be collinear. So we're going to write A, C, and D can be collinear. The third one we're going to look at is if you see a point that is left or right. So basically, before a point, which is called. That means that if you can understand, it is stating the location of a point on the graph or on the picture. We can say that point C is left of point D. We can say that. We can also assume that point C is left of point D. It's not going to happen when a problem says that C is right of D and C is left of D in the picture. If you ever see that happen, talk to your math teacher about it and clarify, because you can't have two pieces of information that would compete with each other. So here are some examples of when to assume things for geometry. Assuming these kinds of examples will help us further with logical thinking and also find what we need to find and where we need to go. We can use and assume straight lines. B and A is a straight line. If something is collinear or non-collinear, A, C, and D is collinear with each other. And before a point, that means that C is left of D. If you can visualize it and understand it, then it's probably mean that you can assume it.
Take that!
Is that the bag the defendant hid in?
Yes, but there's one thing that's been bothering me. If the defendant really was hiding in this bag, then how did he tie the knot from the outside of the bag? What? If he was inside the bag, it'd be impossible for him to tie that knot on the outside.
But then, how did he do it?
It's simple. He didn't. What are you saying? I'm saying my client wasn't hiding in that bag at all. He was stuffed in there. By this very witness!
What?
As you can see by this doctor's analysis, the defendant had taken quite the beating. While he was in the bag, he was unconscious. This is absurd. The witness was attempting to dispose of the body. He left the defendant in the bag, knowing he'd drive by it on the way back to the bank. When the witness and his partner passed the bag, he convinced his partner to throw the bag in with the others.
But why would he do that?
Why, to dispose of the body, of course. There were millions of bags of money in that bank, and the witness knew it would take a long time before the victim was found. But unfortunately for the witness, His victim woke up and tried to escape from his tomb. He was arrested on the spot, and the witness thought everything was over. It's come back to haunt him now. You can't be happening to me!
Well, that certainly was an interesting trial. However, I am now ready to deliver my verdict. I find the defendant, Henry Stickmin.
But what happens when you can't assume something? What happens if there are things in geometry that you can't assume? Well, that is what we're going to look at next. So, when you do geometry and when you assume things, sometimes people make mistakes. What we can't assume unless it's given to us or a special symbol is marked on the picture, we cannot assume right angles. That means that you may think that this looks like a right angle. However, you can't do that because even though it looks like one, that angle could be like 89.99999999999999999999999999999 degrees. Well, continuing. So, right angles have to equal 90 degrees. And even though it looks like a right angle, it might not be a right angle because it might be off like what? 0.1. So you can't understand, well, you can't guess if something is a right angle or if something is an angle. The other thing we can't do is we can't assume that it's congruent. That means two angles or two lines or two shapes that are the same. It means we can't say that BC can be congruent to EB. We can't say that because there's no proof of it, and the problem's not giving us any information about it. The third one we can't do is reciting the sides of angles and segments. The reason why we can't do that is, if you look at the picture here, sometimes geometry is not what you think. Just like how this may not be a right angle, we could also say that DE can be longer than BC. If the problem says that BC is bigger than DE, then you can use that. But what you see right in front of you looks like that BC is larger or longer than DE. You can't do that because DE might be bigger than BC. So no matter how big something is in the picture, you can't exactly assume its size. Because maybe it's big, maybe it's tiny, or maybe it's ginormous. So you can't really guess or estimate, or you can't really assume that the measurements are that because of the size that looks like the picture. However, we can start assuming the don'ts if the problem is given to us, like we're going to say that BAD, angle BAD is a right angle. It'll only work if it's given to us, or if you see this as a symbol, or if you see marks. The marks apply to congruency, so the marks can be like this. This can be congruent to this, even though it's not shown actually, like it doesn't look like it. The two lines right here are not congruent. So if there's symbols, if it's given to you, or if you can prove anything about it, then you can break the rules with the don'ts.
And didn't hide himself in that bag.
Well then, what are you waiting for? Present this evidence already.
Take that!
What is this?
It's evidence.
And how exactly does this prove anything?
Well, I was just kidding. Let me try.
This is no time for jokes. I see no reason to further prolong this trial. I find the defendant, Henry Stickmin.
And that is how we can assume things and when not to assume things in geometry. Thank you for watching Tao Ping Analyze the Math Industry. Like and subscribe.